When any fuel is combusted along with oxygen at high temperatures, it creates a harmful emission known as nitrogen oxide, or NOx, which is a combination of nitrogen and oxygen. In order to reduce these NOx emissions, an exhaust gas recirculation, or EGR, system has been developed. Various countries, states, and cities have different requirements. In cooperation with the Environmental Protection Agency, or EPA, and the European Environment Agency, or EEA, vehicle manufacturers will produce EGR systems to reduce NOx emissions based on the locations in which the vehicles will be used. For example, a vehicle in California follows California Air Resources Board, or CARB, which may have more stringent NOx emission requirements than Ohio or Texas. The EGR system is comprised of several major components, such as an EGR valve, EGR cooler, and EGR mass measurement devices that connect the intake manifold and the exhaust manifold to reintroduce exhausted gas into the combustion chamber at a lower temperature in order to reduce NOx emissions. The EGR valve is the main control device that opens and closes to regulate the flow of exhaust gas and is located before or after the EGR cooler. An EGR cooler is a heat exchanger that accepts hot gas on one side and reduces the heat significantly as it goes through a series of channels and comes out on the other side of the cooler. The gas is confined inside the plumbing and is often bolted together, which connects the intake manifold and exhaust manifold to create a loop. EGR mass measurement devices are used to monitor the amount of gas flowing through the EGR system, and temperature sensors are used to monitor the temperature of the gas. The measured information is transmitted to the engine control module, or ECM, which signals the EGR valve to open or close. The entire EGR system is bolted together with individual components, or it is shipped to the original equipment manufacturer, or OEM, in a module or pre-built condition